This is my lecture on Lab 7, Synthesis and Analysis of Alum. This is a virtual lab. Experimental data will be given to you for you to write the lab report, as if you had done the experiments and collected those data. In this experiment, you will mix aluminum, potassium hydroxide, and sulfuric acid to make alum. First, I want to introduce you to this vacuum filtration technique with a Buchanan funnel. This is a Buchanan funnel. I'd like you to watch this YouTube video to learn how to do vacuum filtration. In this lab, potassium hydroxide and sulfuric acid are strongly corrosive. In this lab, you will perform vacuum filtration twice. The first time is to remove some impurities from this potassium aluminum hydroxide solution. This is made by mixing aluminum, potassium hydroxide, and water together. The second time doing vacuum filtration is to separate your final product, alum, from water. Before the second vacuum filtration, you need to pre-weigh the dry and clean Buchanan funnel and a filter paper. Why is that? The reason is, if we know the mass of Buchanan funnel plus filter paper, then after this vacuum filtration, we can simply leave the product inside the funnel on top of the paper and weigh the whole thing. The mass of the funnel plus paper plus alum minus the mass of funnel plus paper is going to be the mass of the product. Before we weigh the product, we need to make sure the alum product is completely dry. So after the filtration, we use 50% ethanol to rinse the product. Ethanol has a very low boiling point, so it can take water away from the alum product, and itself can evaporate really quickly. So again, after the filtration, after the alum product looks dry, we can weigh the product inside the funnel on the paper, and then this number subtract this number will be the mass of the product. The formula of the alum product is here. Its molar mass is 474.4 gram per mole. You will need to use this number in your calculations. When the product is dry, we can also measure its melting point and compare your melting point with the literature value. If your melting point is close to 92 degrees Celsius, the product is pure. If your number is much lower than 92, your product may not be pure. Watch this video on the measurement of melting point. Now I'm going to give you the data for you to write the lab report. You got the mass of Buchanan funnel top and filter paper. Actually, you don't need to use this number in your calculation. It's here to remind you to always consider weighing the funnel top and filter paper before the filtration of the product. Assuming the mass of KOH you used is 4.001 grams, the mass of aluminum is 1.001 grams, you used 20 milliliters of 9.0 9.0 molar sulfuric acid. And 9.0 molar is equal to 9.0 moles per liter. So you can convert this to liters first, and then multiply that by 9.0 mole per liter to get the number of moles of sulfuric acid. And also, let's assume the mass of the final dry product is 12.001 grams. The melting point of your product is 89 to 91 degrees Celsius. So this data will be used for you, by you, to write the lab report. Now I'm going to explain why an ice bath is used in this experiment to help facilitate the precipitation of alum. We can look at the solubility of alum at 0 degree Celsius. It's 3.9 gram per 100 grams of water. At higher temperature, this alum has a much higher solubility. So assuming you dissolve 134 grams of alum in 100 grams of water at 80 degrees Celsius, and then you cool the temperature to 0 degrees Celsius, well, very likely 130 grams of alum will precipitate out of the aqueous solution. Now I'm going to talk about some theoretical calculations. I'm going to explain the limiting reagent and theoretical yield. So this is a ice cream sundae analogy. Let's say you have 2 scoops of ice cream, 1 cherry, and 50 ml of syrup. You can make one sundae. You put the ice cream here, and then you add a syrup, and then you put 1 cherry on top. It's a nice sundae. And now let's say instead of 2 scoops of ice cream, I'm going to give you 8 scoops. So it seems that you can make 4 sundaes, right? And then instead of 1 cherry, I'll give you 6 cherries. It seems that you can use 6 cherries to make 6 sundaes. And then I'll give you 100 milliliters of syrup. Well, 100 is twice of 50 milliliters. So this can help you make 2 sundaes. Now I'm going to give you again 8 scoops of ice cream, 6 cherries, 100 ml of syrup. How many sundaes can you make? Only 2. So if you just look at the ice cream, you can make 4 sundaes. If you just look at cherries, you can make 6 sundaes. But if you look at the syrup, you can make only 2. So syrup is the limiting reagent. Now let's get back to the real chemical equation. It's aluminum react with potassium hydroxide, 2 sulfuric acid, 11 water. This is a product. And hydrogen is another product, although we don't care about hydrogen that much. Now let me give you some numbers. Let's say you have 2 moles of aluminum, 3 moles of KOH, 24 moles sulfuric acid, 99 moles of water. Now, how many moles of alum can you make, theoretically? Well, if you have 2 moles of aluminum, there's a 1-to-1 ratio here, then you can make 2 moles of alum. 3 moles of KOH, okay, 1-to-1, then you can make 3 moles of alum. 24 moles of sulfuric acid. There's a 2-to-1 ratio, so 24 moles of sulfuric acid can be used to make 12 moles of alum. 99 moles of water, there's a 11-to-1 ratio over here. Look at the coefficient here. And here that means you can make only 9 moles of alum, given 99 moles of water. Now I want you to compare these four numbers: 2 moles alum, 3 moles alum, 12 moles alum, 9 moles alum. Find the smallest number, 2 moles. So that means aluminum is the limiting reagent, and you can only make 2 moles of alum. KOH, sulfuric acid, and water will be in excess. Therefore, the theoretical yield is 2 moles of alum, or you can convert it to grams. The molar mass is given to you. This is the theoretical yield. But what if you actually did the experiment and you got only 700 grams of product? Then the percentage yield is the actual yield, 700, divided by the theoretical yield, 948.8. The result is 73.78%. That's your percentage yield. Your percentage yield is always less than 100%. If it's higher than 100%, either your calculation is wrong or there's just too much impurities in your product.